Welcome to the Math Record. Today I'll be covering the second part of the ICTM State 2018 Division AA Freshman Sophomore 8%, which I'll be answering questions 15 and 17. Okay, question 15. Region R is bounded by lines y equals negative x plus a, y equals 2x plus negative 2x plus a, and the x-axis. The region is rotated 360 around the y-axis. Find the total numerical area, which is in this form, add the coefficients basically. So let's kind of graph this. Okay, and we have this line. And then we have negative x plus 8. So x plus 8, let's say right there. And then we also have negative 2x plus 8, so start at the same point, a larger slope. So the y-intercept is 8, x-intercept of this is 4, and this one's 8, and then the x-axis. So we're looking for this region that's rotated 360. So all we have to do is that we need to rotate this line 360 and this line 360, and that basically give us our solid. And that solid, we have a surface area that's made by this line, which is basically a cone, and we have another cone inside it. So we have to find the lateral surface area made by this line, the lateral surface area made by this line, and then we have to find, basically since they're making a cone, there's got to be a circular base, right? So we have to find the circular area of this, and then the circle area of the bigger one, and then subtract those two areas to get that area in between. So what we're going to do is just follow the formula, which is pi radius slant height, which is lateral surface area. So for the bigger triangle, we have pi, or your radius is 8 because your x-intercept is 8, and your slant height is 8 squared plus 8 squared, and then take the square root, which is just 8 squared 2, because that's just a 45, 45, 90, or a isosceles triangle, basically. 8 squared 2, I mean. Yeah, 8 squared. And then for the smaller lateral surface area made by this line, we have a radius of 4, so pi 4, and then slant height is 8 squared plus 4 squared, so that's 64 plus 16, which is 80. Square root 80 is 4 squared 5. Okay, and now to get the circular basis, so pi radius squared. So the radius of this is 8, so that's pi times 8 times 8, and the radius of this is 4, so that's pi times 4 times 4. So we have, so our total surface area will be 8 times 8 times square root 2, which is 64 square root 2. And then this is 16 square root 5. And then this one would be 64, and this one would be 16. 64 minus 16, that is 48. So that's plus 48. And then they're all multiplied by the pi. So you see the coefficients, all you have to do is just add them up. So 48 plus 64 plus 2 plus 16 plus 5. So that is going to make 80, 82, which is 120, 130, plus the 5 is 135. And that is your answer for number 15. So all you have to do is recognize that they're cones and just follow the formula. Okay, question 17. Determine the smallest of three consecutive positive integers greater than 7 that are divisible by 5, 6, and 7 respectively. So the easiest way to do this basically would be, if you kind of think about it, the smallest three consecutive integers that are divisible, ignoring this constraint that's divisible by 5, 6, and 7 is 5, 6, and 7, right? So what is the next numbers that are three consecutive integers that are divisible by 7? Well, if you think about it, if we make a multiple of 7 and add it, multiple of all these three numbers and add it to these three numbers, then basically they're going to be another three consecutive numbers, but they're also divisible by 5, 6, and 7. So to get the number that's divisible by all these three numbers, just look for the least common multiple. So the least common multiple of 5, 6, and 7, that's 5 times 6, which is 30, times 7 is 210. So add 210 to these three numbers, so 215, 216, and 217. So you divide this by 5, that's divisible by 5. Divide this by 6, that's divisible by 6. Divide this by 7, that's divisible by 7. So that basically tells us that the smallest of the three consecutive positive integers greater than 7, since 2015, 2016, and 2017 is greater than 7, then the smallest is 2015, and that's your answer. But basically, if you want to look for a more mathematical way to kind of prove this, would be if you kind of have your three consecutive integers as x, x plus 1, and x plus 2. You could rewrite it as 5a, where a is an integer, 6b, b is an integer, and 7c, and c is an integer. So then basically x is a 5 multiple, the next consecutive is a 6 multiple, and the next consecutive is the 7 multiple. So then when we put this all in terms of x, subtract 1, subtract 2, so that gives us that 5a is equal to 6b minus 1 because they're both equal to x. So we're just going to have these two equations first. So first we need to find a multiple that works, find a value for x that works for both of these. So if you kind of think about it, you plug in a is equal to 1. We just need to test points. That's 5. 5 plus this one is 6. 6 divided by 6 is 1. So that means they're both integers, so that means the smallest is 1 and 1. So plug in 1 into these values and you get 5. So that means the first value that works is 5. So what is the next value that makes sense? Well, the next value has to be a multiple of a 5 and a 6. So that's going to be 5 times 6 is 30. So that's 30 times some kind of integer. So let's just choose a new variable and let's call it d. So this would be our integer, and this is going to be our new equation for a multiple that has to equal your 7c minus 2. Because this multiple works for these two equations, but we need all these three equations to work. So we need to set this one equal to this one, so then we have all of them to work. So 5 plus 30d equals 7c minus 2. So we're going to do the same thing again. So this is 7 plus 30d equals 7c. So what value of d will work to make c an integer? So if you kind of think about it, we divide by 7. That would be 1 plus 30 over 7d is equal to c. That means the smallest value for d has to equal 7. We plug in 7 here. That means c is equal to 31. So to find the value that works, plug in 7 to here, the first equation, because these are the equations. So plug in 7 here, that's 210, plus the 5 is 215. And it's the same case here, it doesn't matter which one you plug in. So 217 minus 2 is 2015. So that would be the smallest integer. And that's how you kind of find it mathematically also. Well, thanks for watching, and I'll see you at the next math record.